Diabetes is a condition where the blood sugar level is too high. Either the body isn't responding to the insulin being produced, or the pancreas cannot make insulin. Fortunately, we can use bacteria to make insulin, and this is where genetic engineering meets medicine. Firstly, we'll take a trip to the beta cells of the pancreas. All cells contain DNA, which is like an instruction manual. Over here, this cell is making copies of the part of DNA which has the recipe for insulin production. Scientists can use the copy, or they can use the gene itself. In the next step, the insulin gene is placed in a thermocycler to generate many clones. You could think of the thermocycler like a photocopier, where you insert the file. The machine produces many copies of it, but instead of ink, our thermocycler would contain enzymes and DNA bases. However, our bacterial cell will not pick up the insulin gene in its bare form. You could say it refers to its science books. So what I am going to do is I will insert the insulin file in a science book, and as you can see, our bacterial cell has already picked up our insulin gene. What is actually done is that a plasmid is cut using restriction enzymes, and our plasmid is a small circular piece of DNA, like a simpler version of the instruction manual that our pancreatic cells had. The restriction enzymes make sticky ends in our plasmid, which allows for the insulin gene to attach. However, sometimes the plasmid would end up sticking back to itself. So having known this, when we introduce the plasmids to a pool of bacteria, there will be some bacteria who take the plasmid with our insulin gene, some who take a plasmid without the gene, and some bacteria who don't take anything. We can then test to identify which bacteria contains our recombinant plasmid, allow it to grow, and then harvest the insulin that it will produce.